Hello everyone, I'm Sam. Huawei Optics transmission equipment provides multiple DCN solutions for different networking. At first, let's have a look at IP DCN.
This section provides basic information about IP DCN. Huawei's IP DCN solution allows an NMS to manage NEs by encapsulating NMS messages in the IP protocol stack and transmitting them over the DCN channels between the NEs. If a network has only RTN300s or a combination of RTN300s and third-party equipment supporting the IP protocol stack, using an IP DCN is recommended. To implement IP DCN, equipment must support the IP protocol stack. IP DCN uses the standard TCP/IP protocol stack architecture. Layer 1 of the protocol stack is the physical layer, which provides data transmission channels for data terminal equipment. The RTN300 provides the following DCN channels: NMS port, all the bandwidth at the NMS port, DCC channel, 3 Huawei-defined DCC bytes in a microwave frame at a microwave port, in-band DCN, a portion of Ethernet service bandwidth at an Ethernet or microwave port. Layer 2 is the data link layer, which provides reliable data transmission to the physical link layer. DCCs and in-band DCNs use the PPP protocol to set up data links. Therefore, IP addresses of adjacent NEs do not need to be in the same IP network segment. Layer 3 is the network layer, which specifies the network layer address for a network entity and provides transferring and addressing functions. NEs implement network layer functions using the IP protocol. The routes used for IP transferring can be direct routes discovered by running link layer protocols, manually configured static routes, or dynamic routes generated running the OSPF protocol. The RTN300 provides various OSPF features. For details, see the specifications. Layer 4 is the transport layer, which provides end-to-end communication services for the upper layer. NEs support the TCP/UDP protocol. In IP DCN, the packets are transferred in either gateway access mode or direct access mode. In gateway access mode, packets are transferred as follows. The NMS transfers application layer packets to the gateway NE through the TCP connection. The gateway NE extracts the packets from the TCP/IP protocol stack and delivers them to the application layer. The application layer of the gateway NE queries the destination NE address of the packets. If the address does not belong to the gateway NE, the gateway NE queries the core routing table of the application layer. The gateway NE obtains the route to the destination NE and the communication protocol stack of the transit NE according to the destination NE address. Because the transit NE uses the IP protocol stack, the gateway NE transfers the packets to the transit NE through the IP protocol stack. The network layer of the transit NE queries the destination IP address of the packets. If the address does not belong to the transit NE, the transit NE queries the IP routing table to obtain the route to the destination NE and then transfers the packets. The network layer of the destination NE passes the packets to its application layer through the transport layer because the destination IP address of the packets is the same as the IP address of the destination NE. The application layer then processes the packets. In direct access mode, the packets are transferred in a different way. The original gateway NE acts as an ordinary transit NE, and packets are transferred at the network layer. In actual networking, the RTN300 often connects to a third-party L2 network. In this scenario, enable the access control function at the RTN300 Ethernet ports to allow IP DCN packets to traverse the L2 network. When the third-party L2 network is located between the NMS and the network comprised of RTN300s, the L2 network transmits Ethernet services and DCN packets between the NMS and the gateway NE. In this scenario, the NMS uses the LAN switch to remove the VLAN ID carried by NMS messages, and the access control function is enabled on the Ethernet port. After the access control function is enabled, The Ethernet port functions as an Ethernet NMS port on the gateway NE. The IP address of the Ethernet port must be in the same network segment as that of the NMS IP address and in a network segment different from that of NE IP addresses. The NMS communicates with the gateway NE based on the IP address of the Ethernet port. When the third-party L2 network is located between two networks comprised of RTN 300s, NMS messages are encapsulated as L2 services for transmission. In this scenario, the access control function is enabled on the Ethernet ports of two networks for connecting to the third-party L2 network, and their IP addresses are in the same network segment. The third-party L2 network creates a dedicated L2 VPN service for the DCN packets carrying a specific in-band DCN VLAN ID.
That's all for today. Thank you.